So on these first few that we are going to take a peek at algebraically, basically the directions are up at the top of the page. We're going to isolate the radicals when possible. As long as I only have one on a side, that's okay. Then we're going to square both sides. We'll talk a little bit more about how those can get a little more complex. And then we're going to check for what's called extraneous solutions, or answers that don't work. You're like, I can solve an algebra problem and do it right, and the answer doesn't work? It's true. It does happen at times. So on this first one, I can't isolate the radicals anymore, because if I subtracted one over each way, I'd have two on a side. So step one's done. Step two, we're going to square both sides. And the reason we do that is squared and square root are inverses. They're opposites. And so what happens is the squared just gets rid of the radical portion. So all we're left with is what's underneath. And now we're back to an Algebra 1 problem. Just that quick. So I'd go ahead. Some of them there will be more to it. It's true. 9 minus 8 gives me 1m. And I get my answer, but before you circle it, ponder for a second, does this answer work? You're like, well, how do I know? Well, let's plug it in. If I plug in 1 here, 9 times 1 is 9. The square root of 9 is 3. If I plug in 1 here, 8 times 1 is 8, plus 1 is 9, which is 3. Okay, that one worked. I just got to check for a second to make sure. And I'll even give you a hint here in a little bit on how you might be able to not necessarily have to check, but just check certain answers. But we'll get there. So as we start to move forward, Dan just said a minute ago, there's going to be a little more to it. It's too good to be true so far. So if I can isolate my radical, and in this case I can, because that minus 4, I don't want that over here. That would cause me a big mess when I went to square things. So I'm going to do my opposite. Okay. Once that radical is isolated, and it is now, I can go ahead and do the same types of things that I was doing in the first one. I'm going to go ahead, and I'm going to square both sides. Now here's where the caution comes on this one. Squared and square root cancel. Okay. But on the other side, there's not a radical to cancel it out. This is actually 8 squared, or 8 times 8, which is 64. I can't just assume and write down 8, or I'm not going to get the right answer. So as I'm doing that, go ahead. I isolate my n by minusing the 40 over. And then I just divide by 3. Oh, bless you. But again, take a quick moment to make sure things are going okay. So if I plug this back in, let's see what I get here. I got 4 equals 8 times 3 is 24, plus 40 is 64. Square root of 64 is 8. 8 minus 4. Yep, that works. Okay. No, but here's what I'll tell you. When you get to your unit quiz, I can almost guarantee I will make sure at least one of the questions has an answer that doesn't work to see if you're paying attention or not. So, but no, you don't have to check every single one.
That's a while.
That's a while from now. Okay. And then our last one on this page before I start kind of showing you some other options. Now, this one also gets a little tricky because, remember, trying to isolate the radical. How am I going to get that 8 out of there? Okay, we got to divide this time. So any operations are fair game. And now it looks like the other ones. Square both sides, dump the radical, and then just divide. So it's not a bad deal. And again, I'll just kind of take a quick peek here. 3 times 12 is 36. The square root of 36 is 6. 6 times 8 is 48. Okay, that's good. You're like, does it seem as though finding an answer that doesn't work is going to be as rare as it's been going so far? More than likely. Usually it is. It doesn't happen a lot, but it does happen occasionally.
Are they graphing to or no?
We're just going to do a quick review of some things with graphing. Okay? So as we get here to the back, I'm going to start giving you some options. Okay, solve the equation, check for solutions. You're like, okay, these look like the rest of them. So, my radical's isolated. That's nice. I'll go ahead, square both sides. Okay. So that's x squared. Okay. Here's where life changes. If you have an x squared term, okay, we're going to get all terms to the x squared side because we are going to have our first dance with the Algebra 2 F word for this semester. Factoring. Okay. So, and some of you might say, well, why don't I just move the x squared to the other side because then it'll only be one step. Negative x squared when you're trying to factor is not something you want to deal with. So what we're going to do is we're going to add the x and minus the 56 from this side. We basically want the one side to be equal 0. We want everything wiped out. And then x squared plus x minus 56. And we go into factoring mode. But again, the nice thing with these are you're not going to get anything where we need to slide and divide or do anything fancy. They're all going to be diamond type problems. So just a refresher. Remember, we're trying to multiply to get the number on the end and add to get the number in the middle. And there's always hints involved with this. For instance, nice, okay. If I'm multiplying to get a negative, I know one has to be negative and one has to be positive. I also know if I'm adding to get a positive that the positive number has to be bigger. So two numbers that multiply to 56 that are 1 apart would be 8 and 7.
Is there any other way to do these?
I'm going to show you in a second. Yeah, there's going to be two options on these. And once I get here, I just do my mini equations and get my answers, but ooh, was I too fast in circling both of them? What's that? Well, let's see. Let's try this. If I plug in negative 8, so that would be negative 8 equals the square root of 56 minus negative 8. Okay, so we know that when we minus a negative, we get plus. So what's the square root of 64 equal? 8. Does it equal negative 8?
No.
Now, does that mean every time you get a negative answer, it won't work? No, but more times than not, if there is going to be one that doesn't work, it's probably going to be the negative one. So if I plug in 7, 56 minus 7 is 49, and the square root of 49 is 7. Okay, so that one worked. That's what I mean by we got to check to make sure that our answers actually work. Now some of you are like, okay, that's just, there's a whole lot to that. Is there another option? Yes, there is. If I go to the calculator, we can do this graphically. So here's how that would work. I'd go to my y equals. The left side is just x. So on the first line, I just type in x. And I go down. The other side of my equation is the square root of 56 minus x. Okay, so I'm literally going to type both of them in. Now, here's the part that some people don't like with this. But again, it's kind of your thing. If I go to graph, that place where they cross, that's the answer. How do I know what that is? Well, I got a couple of options. I can go to the second trace menu and ask the calculator, okay, where do they intersect? And it'll ask me first curve, second curve. Notice my cursor's on the straight line right now. Okay, I'm just going to hit enter. Okay, second curve, notice now it's moved. It's my curve. Again, I'm fine with that. enter, and 1 for the guess, and check me out. The x value is the answer. X equals 7. Woo! I'm done. Now, what could go poorly with this? Well, what if the intersection's not on the screen? Then I got to mess with the window. Yeah, I was going to say, sometimes messing with the window can be more of a pain than dealing with the algebra. So it just depends on what you want to do. But here's the positive. Notice I would have never thought that -8 was the answer because it doesn't intersect there. So I'm not going to have extraneous solutions to necessarily think about. So it's one of those things, you know, they both have their positives, but they both have their negatives as well. But it's not always never going to work. Sometimes it can. Just saying. I guess you could gamble if you wanted to and assume that the negative is not going to work and cross it out and cross your finger. You could. There will be a... Wait, points for what?
For like, because before when we would show like checking it,
Mm-hmm.
you would either give us points or you wouldn't give us points.
When, okay, that's a good question. The question is, if you couldn't hear it out there in video land, the whole work thing with this. If you're doing it by a calculator, there's really not going to be any work to be shown. That's true. But here's what I will mention. When we get to the quiz on this, there will be some that I will ask specifically for algebraically. Some I'll give you a choice. So what I've always threatened is if I get too many people that are just jotting down answers or playing around with guess and check, that I'd start making fractional answers. I don't want to get to that, but it's just one of those things that as long as...
If you want to, you probably should, but you don't really know yourself, type thing.
Kind of.
So can you get 2 answers for these?
Oh yeah, you absolutely can get 2 answers for these. Because when you're doing these, okay, and again, I'm going to move everything to the x squared side. So basically by moving it, I'm just changing signs. So the positive 13x when it moves to the other side becomes negative. The negative 36 when I move it to the other side becomes positive. Okay? And again, I have clues. And again, factoring is not going to go away. So I'm a proponent of doing it algebraically because you're going to have to be able to do the factoring sooner or later. There aren't going to be always places that you can avoid it. Now, here's my positive this time. I'm multiplying to get a positive answer, which tells me the signs will be the same. They're either both positive or both negative. Well, if they both add to a negative, it means these are both negative. And 9 and 4. And I set those equal to 0, which basically means I just change the signs. So I get x equals 4 and x equals 9. So is it possible that both answers actually work?
Yes.
Yes.
Can you always get where they don't work? Like
There is a possibility sometimes that you can get 2 solutions and neither of them will work. Then it's just no solution because they would never cross. Uh-huh.
So it's either 0, 1, or 2.
Correct. You can have 0 solutions, you can have 1 solution, you can have 2 solutions.
They can all, and they can all be correct.
Mm-hmm. Because if I plug in 4, so 13 times 4 would be 52, minus 36 would be the square root of 16. So it's the square root of 16 equal 4, it does. If I plug in 9, 9, let's see if I can do this in my head. It'd be 117 minus 36 is 81. Is the square root of 81 equal 9? It does. So both answers work this time. And again, if I went to the calculator and decided I was going to go that route, what you'll end up seeing this time, when I come down to here,
How does what you did at the bottom of that prove anything?
because what I did was when I plugged in the 9 and simplified this, I got 81. So if the square root of 81, this side's just x, which is 9.
Yeah.
Does this side equal this side? Does the square root of 81 equal 9?
Basically, you just take So
Mhm.
then you take the 9 and put it in wherever X is.
Correct.
basically, and
Yes.
then do the same thing with 4.
Correct.
And then just hope you get like,
The two sides equal, yes.
all right.
Uh-huh.
Thank you.
Sure. And so if I graph on this one, now this one it's trickier to see because you're like, well, there's a curve, but like I think it, bless you, I think it covers it in 2 spots here. You know, how do I know for sure? Well, there's a couple of ways, and this is the part where it can get a little tricky. If I do my intersect, okay, there's my first curve, okay. Now second curve, you're like, where is it? I don't see it. See, this is why I'm not as big a fan of that. Oh, there it is, okay. And I hit enter. Now it tells me there's one at 4. I see that, but you're like, what if you don't do it again and there's another one at 9 and you don't know it? Here's my one other way I could try this if I'm not sure. Sometimes I may get lucky, and if I go to the table, if you see the same values in the 2 y charts, okay, y1 and y2, that's a solution. I look at the x value, it's 4. If I keep scrolling down, notice when I get here, the y's are the same, and there's my x. So there's my 2 solutions if I wanted to look at it this way.
Are you gonna go the other one?
I am.
You said
I'm. Great minds think alike. That's where I was heading next
Are
anyway.
we just doing one more? Or 2 more?
Well, I'm going to do at least 7. I might do 8.
Whoa.
Whoa.
These are we gonna do?
Okay. Patience.
No, not 7
Patience.
problems.
Patience.
No, I know,
I-
but did you do that?
Patience.
This is graphing.
Patience.
I haven't gotten to that.
Well, we got to work on that.
chill, just chill. Just chill.
Okay. Here comes the warning problem of the back. On the left side, those just cancel. Okay. On the side. On the left, you cannot just distribute the squared. I can't just write n squared plus 16. It doesn't work. You have to FOIL or box this out. Seriously.
So much work.
Oh my goodness. I know life is
The 9
over.
points are so rough. This is just notes.
So basically I'm going to take, I have 2 of those n minus 4s. And what I'm going to do is I'm going to multiply again, just careful with signs. Negative times negative is positive.
So doesn't the negative 4 and negative 4 equals
No. That's like if I owe somebody $4 and I borrow 4 more. Now I'm further in the hole.
Oh no.
So negative 4 and negative 4 is negative 8 plus 16. Okay? If I would have just distributed, I wouldn't have gotten the middle term. And I have to do that.
How many problems like this do I have?
Patience.
I'm just asking so I know, like,
Look for the ones that have multiple terms on the one side without a radical. All the terms go to the n squared side, just like they have been.
Wait, what's our homework?
Again, we will get there. With all the time that we're going to spend worrying about that and complaining, you're going to end up missing something that's important or causing us to take more time and give you less time to do anything.
We don't have a lot of time. We got 2 minutes.
So I get all my terms, doing my opposites to the squared side,
7 and 9.
and then I just factor it. Right on, 7 and 5. And again, since I'm multiplying to a positive and adding to a negative, they're both negative.
didn't you say there was another way we can do this rather than factoring or no?
Yeah, he showed
Yeah, I said on the calculator with the graphing. Those are the options. Factoring or doing the graphing.
Yeah, I was
I'm just trying to get out of doing all this work, but.
Either way it goes, it's about the
So-
same amount.
When you box it, is one side supposed to be able to cancel out then?
No, the only time that you're going to have something that cancels out is if I had like n minus 4 and n plus 4. The middle terms
How
cancel,
about-
but they won't here.
Because you got like 4 minus 19, you got negative 4, 9 plus 19. Is that supposed to happen, or is that just?
Over here,
Yeah, and then
This squared and the square root just canceled. That was the only work I did on this side.
This is supposed to do that?
Yeah, that's the whole idea. I'm trying to get rid of the square root, and the only way I can is by doing the opposite, which is squaring both sides.
Right, so that's a regular thing getting it to 0 on one side.
Right. I want to get all my terms once I've gotten rid of the radical. I want to go ahead and get all my terms to the squared side, because that's how I can factor it then. Okay? So once I do that, and I'll help you out here, I'll do the checking for you. They both work.
You say you do the checking for you.
I am on this one. Yes, for time's sake, you know, sometimes they say we cut out portions of the program for time's sake. That's what I'm going to do here. And we're going to get that to work that way. Okay. Now, one more just to let you see how that's working this way. I want to do 8, and then I'm going to do some trimming to the homework because I'm considerate of these things.
Well, you know, I wasn't complaining about the homework. I just wanted to know what was the homework.
I will say that I was complaining about the homework. I don't care.
Okay.
Okay, then.
Just letting you on.
So, one more time, just to make sure we've got this part of things down. Again, I've got my radical isolated, so I can go ahead and square. But I do notice that my left side is a binomial. There are 2 terms, so I've got to FOIL or box that out. So the right side, if my pen works, there we go. And I'll continue to say that I will suggest for most of you that using the box is going to be your best route, because that way you're not going to forget terms. And we're just multiplying what's on the edges. Again, negative times negative, we're multiplying to fill the box. And once I get there, okay, x squared, there's my like terms. They don't cancel, they're not opposites. Negative 7 is negative 14. And then again, I get all the terms to the x squared side. So I'm going to plus the 3x. I'm going to minus the 21. So all that stuff goes away. Yep, and again, just look for the clues. Multiplies to a positive, which means they're both positive or both negative. Well, I know they're both negative because that's my sum. And I already heard a couple of you say 7 and 4. And then again, when I set those equal to 0, I basically just change the signs on them. And once again, for our time's sake here, Okay, here's my hint, and I think this might have been what Michelle was referring to before. If I look at this left side, okay, 7 minus 7 is 0. 3 times 7 is 21. 21 minus 21 is 0. Okay, that one works. Here's where you've got to think about this for a minute, and you can shortcut this process. If I plug 4 in, what's 4 minus 7? Negative 3. Can I take a square root and get a negative out? No. I don't even have to do the rest. Okay, right, that'd be the I thing, and we're not going to do the I thing with these. So if you're going to get something where it says the square root's a negative, that doesn't make any sense. Okay, so here's how we're going to do this for my homework crazed people. Let me switch this over. Let me get the worksheet out.
Where are these fractions? Worksheet? You mean work packet?
No, for today, no, worksheet. Okay.
Didn't worry about these fractions.
Patience, just a second. Okay, we are going to be looking at only the front of the first page.
Well, that's not bad.
Okay, for homework on this. Now, what was just mentioned, I'm going to fix right now. You're like, wait a minute. We didn't do any with fractions. What's up with that? Okay, watch this. This isn't going to take long. I'm going to do number 5. Okay. Isolate your radical if it isn't.
So add 4?
Add 4. You guys are going to wish they were all this way.
Don't you have to square?
Right, because I've got a radical alone. I've got to square it.
It would be 49.
You're on a roll.
X over 2.
49 equals x over 2.
Can I multiply by 2?
You can. Since we're dividing by 2, to finish it, we do the opposite. And we multiply by 2. X equals 98. Okay, let's make sure that works. 98 divided by 2 is 49. Square root of 49 is 7 minus 4. Does that equal 3? It does. Okay, that's it.
And you will
See, we worry about nothing so much. So, knock out this first page. We'll chat some more about these tomorrow, and we'll talk about the graphing a little bit more. Nicely done.